Hello and welcome to another episode of the IT Wildcard. So I've sort of gone back to the original theme of the series. I know I jump around a bit with this series in terms of what area within IT I talk about, and I've had a bit of a run recently of doing ones about CS50, and I will periodically report back about my experience of various CS50 courses going forward. I'm currently working through the AI one, the Introduction to Artificial Intelligence with Python. But what I've decided to do is, in some ways, let the universe, let the zeitgeist guide me. So what do I mean by that? Well, for other episodes in this series, I think what I'll do is I'm going to rely on that phenomenon, I'm sure everybody's experienced it, where suddenly a word you hadn't heard for a while, or a word that you have only just recently heard in a certain context comes up, and it starts to come up with such regularity that you feel that it's coming and being part of the zeitgeist. And so this, I suppose, is the first of that type of video, and then going forward, like I said, I'll do that every time I maybe start to see a word or term or concept that's used in IT, and I'm starting to notice it emerging in my day-to-day with increasing familiarity. I'll talk about it, and today's topic is code smells. And so we're going to take a look at that. In terms of structure, I think what I'll do with this series is I'll dive straight in and we'll do a bit of digging around on Wikipedia, a bit of sort of just-in-time learning. And then I'll go through and focus in on specific things as to how this came about, how I either rediscovered the term or the term came up and sort of came into my own personal zeitgeist at this point in time. So if you're not familiar with the term code smell, which I'm part of the reason why you might be watching this video, obviously a good place to start is the Wikipedia article. I'll include links to everything I'm going to be talking about in this particular episode. So it says, in computer programming, a code smell is any characteristic in the source code of a program that possibly indicates a deeper problem. Determining what is and is not a code smell is subjective and varies by language, developer and development methodology. And you can see here we've got a couple of links here, which are obviously repeated further down in the article. So we've got an interesting PDF there, which might be worth checking out. I'm not going to check out in this video. And another one. Oh, there's one to a website. Cool. So it seems that the term was popularised by Kent Beck on Ward's Wiki in the late 1990s. So the Wiki Web is the first wiki or user editable website. Okay. Usage of the term increased after it was featured in the 1999 book Refactoring, Improving the Design of Existing Code by Martin Fowler. So we have a link there to the Addison Wesley website. It's also a term used by agile programmers. Okay. So I found this bit interesting when I quickly looked through this article before doing the video. So it says, one way to look at smells is with respect to principles and quality. Smells are certain structures in the code that indicate violation of fundamental design principles and negatively impact design quality. Code smells are usually not bugs. They are not technically incorrect and do not prevent the program from functioning. Instead, they indicate weaknesses in design that may slow down development or increase the risk of bugs or failures in the future. Bad code smells can be an indicator of factors that contribute to technical debt. Robert C. Martin calls a list of code smells a value system for software craftsmanship. So, and this is why I'm interested in it, is it's like anything, the more you sort of study common code smells, if you like, the more likely you're going to see patterns in your own coding, and then, that way you stop yourself from generating your own code smells. I think it's a great term, actually. Yeah. And you'll notice, you'll hear the term refactoring come up quite a bit when talking about code smells. I talked about some tools here, which we'll get onto a little bit in a moment. So these definitely look like these are worth checking out. There's even been a survey on code smells. Okay, so good place to start. Let me just see if I can see whether this is still available. Okay, so yeah, I'll include a direct link to that. That looks really interesting. And let's also see what we've got on the original site. So there we go. That's good. So that's a really good starting point now if you want to know a little bit more about code smells. But to me, currently, the other interesting thing about how this sort of, I suppose, came to a head this morning, but what made me really prompt me to do the video is this morning I was having a chat with my wife about what she was working on currently, and we were talking about basically data analysis, and I was talking about my own experience recently of making a mistake on a little bit of personal code I was working on. It wasn't in production code, because nothing I write now is for use in production, really. It's for my own amusement. But I'd made a mistake revolving around to do with I'm trying to think now. So it was basically case sensitivity, case insensitivity. And in the course of just talking about, silly mistakes that sometimes you make when you forget about something, because you haven't really thought about that for a long while, and maybe there's stuff that's taking care of case sensitivity within certain platforms, so that when you're searching this case sensitivity or insensitivity doesn't matter quite so much, and then suddenly you're in a scenario where it does and you don't realise. And so that led on to a discussion about code smells, and I was just saying how I'd noticed the term was being used a lot more, and my wife asked me to sort of explain it, and I then tried to explain it with examples, and it resulted me in actually having to look it up just to confirm that my understanding of it was correct. But in my initial definition, which I was quite pleased about, was this along this line here. This one here. So code smells are usually not bugs, they're not technically incorrect, and they don't prevent the program from functioning. Instead, they indicate weakness in design that may slow down development or increase the risk of bugs or failures in the future. And that's the thing I was really interested in this sort of like bugs waiting to happen. Now, when I think about it through this, of course, I find this very close, and there must be some overlap here between when I was learning programming, people talked about actual bugs and then something called a logic bomb, where you'd be testing it and it wouldn't necessarily be a bug, but then later on the code would start not giving the desired result because there was something wrong in the way you'd structured your logic. So I'm assuming if you were to take like a Venn diagram of this, you might find that there's overlaps between code smells, actual bugs, and although it says code smells are usually not bugs, but often there is always like a grey area, I think, in anything. The dividing line between the two isn't always clear as you start to analyse things and start to categorise. But I'm thinking this Venn diagram with, code smells, bugs, and then logic bombs, and just, is there any point where the different areas of that Venn diagram might overlap? So I'm interested about that. The other thing, obviously, I was curious about, and it seems to have disappeared now, as it often does, was I did do some... Oh, there it is. It's come back again. I hate this. It rolls out off the screen occasionally when you leave. I'm starting to get a little bit annoyed by some of the features, functions, bugs, code smells maybe, that are creeping into Bing, Bing Chat as well, and it's being quite weird. So I asked it a series of questions. I had to break it down in the end. It didn't like me asking quite a complicated multi-factor question about code smells. So I broke it down to, in programming, what is a code smell? So it gave me a pretty good series of examples of what it might be considered to be code smells. It did do the usual thing of giving me references here, so that's pretty handy. How can I detect code smells in my program? So it went on to come up with some ideas, and again, refactoring came up. Talked about static analysis tools as well, which is good. And then how can I refactor my code without breaking it? Because sometimes if you're just refactoring generally to improve your code, like anything, there's a good chance that you can actually break it. It was talking about refactoring in small increments, and not surprisingly, testing code before and after. Probably the most important thing is having a version control system. So if you do break it, it's easy to go back as well. Can you give me some examples of examples in Python of some code smells? And so then this is the bit I had the biggest trouble with. So in preparation for the video, I tried running some of these questions, and it was actually having real problems giving consistent, coherent examples of actual code smells. So this is what about the first attempt wasn't too bad, but it cut off. This one is probably one of the better ones. So again, good areas to be careful of results from these, chatbots, certain things like this. But it gave some, good examples of this, problem of duplicating code where you may have inadvertently written a function twice or variation on a function. Here it's a bit more, the case of it's almost like literally sort of duplicated it with a few changes, and then talks about long methods. I found some examples it gave in other runs I did this of long methods was a little bit strange, and didn't actually show a code example that bared any resemblance to the written description that it gave. Now here I haven't specifically asked it to give a better example, because again I'd noticed that in one or two instances it actually just gave the same example back, which was odd. Again, be very careful if you're using this for coding, but hopefully you are checking these sort of coding examples for their own code smells, their own logic bombs, and their own bugs. So the God object. This is an interesting term, something I'd not really been aware of before in this context. So a God object, a single class or module becomes too large or complex and it becomes hard to maintain and change. A God object is often a central component of the system that depends on many other classes or modules to control its behaviour. A God object can make it difficult to add new features, fix bugs, or replace components without affecting other parts of the system. I notice they also talk about bottlenecks as well in combination. I've seen conversations about bottlenecks in combinations with God objects encoding. I mean, I'm saying it doesn't give code examples of fixing it, but it does give a written example of fixing the previous one, but not always. You can see again here, it gets just chopped off as well. And I am logged in actually. Often if you're not logged in, it will do that. Yeah. So yeah, not very. Yeah, I mean, some of it's good, but yeah, again, be wary. So as I was thinking this through, I also wanted to sort of just go through how I, in effect, stumbled across the term, because I was aware of the concept but just hadn't heard the term code smell. And I think it was about a year ago where I was looking through about programming paradigms and how to teach programming, and I stumbled across this really interesting video which is part of the NDC conferences. It did go out in 2018, so it's relatively quite old, but I just stumbled across it when I was looking, like I say, at programming paradigms and other things and learning. It's a really interesting video, and that's where I came across the term code smell. It was mentioned in the course of the video. So I'll include a link to this so you can check it out. And out of curiosity, I went on to Google Trends and asked it to search on the code smell topic just to see the interest over time as well. So it's interesting how this peaked in 2018. So this is always interesting as well, to look how certain terms that you feel have entered into your own zeitgeist, or that you're becoming aware of, like how that matches up. Is it because there is a sudden interest in this or not? So I did as a topic and then as a search term, and as you can see, this sort of gradual increase. So maybe for me it's got above a certain threshold where, you know, the word's out there a lot now, and I've just been looking at other things, other domains or certain areas of domains where I'm more likely to stumble across that term. And because there's been this sort of slow uptick of interest over time, it's starting to bubble through and come into my own zeitgeist bubble. But the other source more recent, so that was the original source, was this video. And then between then and this morning's conversation with my wife about making mistakes in code and making mistakes in searches specifically, where it really, I noticed it in the last week, which I suppose led on to that conversation, was I'm doing some of these, at the moment, the Python track on exorcism. And I'm slowly doing this because I'm working my way through this in parallel with me studying on the Harvard X CS50 AI thing, which that's taking a lot of my time. So this is just me kicking the tires on this particular website, but also just reacquainting myself with certain concepts in Python. So I'm just working my way slowly through, and if you've never used this before, it's really cool. So when you start off on a track, you've got concepts and exercises, and the two interact with one another. So you learn concepts and there's exercises you can practice to reinforce those concepts. When you start off, it's all padlocked, and then except for the first one, and it has this little light bulb thing. So you click on that, it walks you through the concepts, gives you some exercises to do. And generally the exercises involve you writing functions that perform a certain function. And what's nice about it is has a code checking system, so you can check the code works before you submit it. But at the point at which you submit it, you get the option to revise your code, because then it does runs it through a linter, some sort of static code checking system, and it actually suggests examples where you could have a code smell in there. So it's saying, well, your code's not wrong, but this could come back to haunt you later on, and then you can go back and you can revise it, and then that's an iteration. And so I found that feature really cool, but of course then it reminded me of code smells again. So that's in the course of the last few weeks when I'm doing this. So again, impetus to record this video. But as you tick off here, what you notice is it initially just opens up the next one after it. Sometimes it will skip over ones for whatever reason, and then unlock the earlier one when you do a later one. I've seen one do that. But also, if you want to jump ahead, it'll sometimes unlock some of these because they're based on principles you've learned earlier, but they're of a slightly higher difficulty than the one you did earlier. So I'm going through like this, really. I'm not jumping ahead. I don't know particular desire to necessarily work my way all the way through. I might do, but so this is a great tool for working on, I think, things like detecting your own instances in the way you code, which might bring up code smells or a number of other things as well. I mentioned about linters. I'll include a link to that. And I was reintroduced to linters actually as part of the CS50 course, which I'll come on to in a moment. A couple of things that they use. There was a point, I think, it might have been on the Python course, I think, where we specifically covered linters. I can't remember if it was that or the C component of the actual main CS50 course, but certainly one we were reintroduced to actually physically running a linter in Visual Studio Code, but then subsequently we were introduced to something called Style 50 as well, which simplified that somewhat to some degree. So these sort of linters come under the area of static code analysis or static program analysis. So that's, as it says here, the analysis of computer programs performed without executing them, in contrast to dynamic. I'll come on to dynamic in a moment, include a link to that. So usually performed by an automated tool, with human analysis typically being called programming understanding. Interestingly enough, there is a feature in Exorcism where you can submit your finished solution, even though it's correct, to further review as well, which is quite nice. So you can get people to pick over it as well if you want. So that's pretty interesting. Yeah, so that's static program analysis. So the program doesn't actually run, but it's just, walk through, I suppose, that's where things like parsers can come in for automation. So it goes through, parses the code, and then, looks at the structure. But then there's, formal manual methods as well. And I can remember at school, in the, would have been the late 70s, early 80s, doing what back then was called dry runs. So that was an example of a static program analysis. And we did that on, on paper and pen, really. Just going through, working our way through line by line. I mean, in our heads, I suppose we were imagining them being executed, but we weren't running them on a computer. And that was a big thing back in the day, because I can remember, and I think I've talked about this before, having to send off codes to some place which was part of, I suppose in the US they'd refer to it as the school board. I can't remember what the similar term is in the UK, but these main places that were part of the education system where they did all the accounting, stuff like that. They had these huge mainframe accounting systems, and in the through time sharing and using the system when it wasn't being used for doing number crunching, we got to run our code. So we had to fill in these coding sheets, send them off. It would take a couple of weeks turnaround, and there was nothing worse than you getting the code sheet back and the printout just saying could not run, or there was some sort of bug or stuff like that. So part of the procedure we went through was to do dry runs so that we knew, hopefully our code would run and we wouldn't waste our own time and the time of the computer. So that was always interesting, seeing that, doing it old school. So there's quite a lot of different techniques that you can leverage with static programming analysis. And then you get dynamic programming analysis. So that involves the execution of the programming question, so unit testing, debugging, code coverage. And obviously a lot of this is happening iteratively and in real time, where you're going to be constantly probably running your code anyway to test stuff, test functions. And this is where additional tools come in as well. There's certain tools that we were taught about in Python and other programming languages, which actually you can use to check your functions and make sure they're performing correctly, and set other things as well. And I'm sure factoring in here is things like, setting breakpoints in codes when you run them and those sort of things. So again, a massive amount of different tools that are available as well. And then of course there's a whole load of other tools as well that check for memory errors, those sort of things. I think at one point we were taught how to use Valgrind as well when we were doing C. So it's been really cool, I think, in the last, I would say, 3 or 4 months. It's been nice to do programming in an environment where we have all these tools now available to us, and I've had to revisit things again, but with a whole new set of really cool tools. So that's really nice. And a couple of the tools I use on specifically the CS50 courses is this Style 50, which checks for code consistency. Consistency. And that's really useful. So that really goes, looks at, here it highlights specifically actually what it's doing. So now this one doesn't specifically pick up, as far as I'm aware, code smells. I mean, indirectly it might do it because of some things in the way you structure programming might contribute to a code smell, maybe. So it just highlights errors in the style, whereas, as I've said, when I'm using this platform, I've noticed it specifically mentions the word code smell when it's doing that secondary analysis. So it does initial check to make sure, logically your function works, and then it runs a secondary one when you submit it to say, okay, there's a few other improvements you could make here. Whereas the Style 50 seems to pick up more things to do with spaces where you shouldn't have them, indenting things where it shouldn't be indented, where it's not causing an actual problem when you're running it, those sort of things. So I'm trying to think what else it commonly picks up in my code. Things like where you've got overly long lines, it might want you to break them up, or maybe I think I had one instance where it didn't like the way I was commenting as well. But that's available in Python. And then this other cool tool, which is their Check 50. So you use this before you finally submit your stuff, and it will actually grade your your work for you, tell you whether you've got the functions correct, automatically grade code for correctness, feedback. It's actually also tied into the final submission, so it goes back through it when you submit it, but it does mean you can check your code before you submit it. So that's really handy. Yeah, so it was good fun using this actually. And I think I've mentioned earlier, part of one of the other courses, we learn how to write our own code checkers as well for checking functions, which was pretty cool. And it was cool that they had written checks to check the checkers, which I thought was really amusing. So anyway, that's where this video sort of ended out. So initially, I was just looking at the code smells, and then really just going through how I came across the term originally, and also how I'm seeing other connected aspects of code smells coming up as I'm starting to, formally do, programming courses again. And this is a great example. I'm working through examples in Python actually, which I, already have done before, but it's really nice to revisit this and ask yourself, okay, coming back with a fresh set of eyes, with all these linters, knowing about code smells, knowing about things to do with, not so much in Python but more in C, I suppose, to do with memory allocation problems, stuff like that. How would I refactor my code? Is there anything I would change? And I find I'm changing things a lot over time, and revisiting certainly code structures. I'm really interested in aesthetically how code looks on the page, and when you look at a certain language, what is the sort of standard way that you should really lay out your code in that language. And of course there's other things you can look at which help with that, like there's coding standards as well, which I was made aware of again actually when I was doing the Python course on CS50. So thanks once again for listening. Hopefully this was informative. Hopefully you like this sort of new way of doing these question and answer things, where I more take a question from the universe, so to speak, as I'm coming across these terms day to day. But again, if there's a question in IT, a rabbit hole you'd like me to go down, I'm still open to doing that. So please, post any in the comments section. Bye for now, and I will catch you in a future video.